Welcome to today's Explainer. We're diving straight into something genuinely fascinating today, the Rihan Atomic Model. We're going to take an impartial look at a theoretical framework that pretty much turns how we visualize the universe's building blocks totally on its head. So whether you're a hardcore particle physics nerd or just someone who loves a good visual way to wrap your head around reality, let's break this thing down.
Okay, let's dive into this. What if almost every single particle in an atom was made of the exact same building block? Sounds wild, right? It totally flies in the face of what we all learned in standard science classes. But what if the difference between the particles that make up you, me, and literally the stars wasn't about the ingredients, but just how they're positioned in space? That is the radical premise we're unpacking right now.
To get our heads around this, we've got a clear atomic journey mapped out. We'll start with a new atomic vision, then get into the geometry of particle identity, followed by navigating the atomic layers. After that, we hit the Central Pyramidal Body, and finally, we'll weigh theory versus reality. All right, part one, a new atomic vision. So, the Rihan Atomic Model, or RAM for short, isn't just some minor tweak to the classical Bohr framework. It's a complete overhaul. Just look at the contrast. The standard model relies on static, multi-quark composites for nucleons. Basically, protons and neutrons are recipes made of different smaller particles. But RAM throws that out the window. It proposes a unified, orientation-dependent single-quark architecture. It strips away all that multi-ingredient complexity and replaces it with a highly simplified, totally dynamic foundation.
In this framework, the magic number is simply one fundamental building block. Under the Rihan model, protons, neutrons, and electrons are all constructed from just a single quark. Yep, you heard that right, just one. Which brings us to part two, geometry of particle identity.
Now, you might be asking the incredibly obvious question: if protons, neutrons, and electrons are all made of the exact same single quark, why on earth do they act so differently? Like, why is an electron negative and a proton positive? Well, what's really interesting here is how the model solves this riddle using pure geometry. It all comes down to the particle's directional orientation in 3D space. The model uses Euler's rotation formula and these successive 90-degree shifts called Faraday quarters. Basically, depending on how that single quark is mathematically rotated in space, it gets its unique electromagnetic signature and charge polarity. It's not a different ingredient at all. It's literally just facing a different direction.
And these little single quarks are busy. They follow continuous circular orbital paths, but it's not just a simple flat circle. The orbit is modulated by a secondary torque, kind of like a spinning top tracing a wide circle on a table. This secondary twisting motion whips up what's described as a thin, Gaussian envelope-like electromagnetic surface that completely surrounds the particle's path. Moving right along to section 3, navigating the atomic layers. Let's zoom out a bit and see how this actually builds an atom. As we descend into the architecture from the outside in, we've got to understand the forces holding the whole thing together. It's a constant, perfectly balanced push and pull. You've got self-attraction pulling everything inward toward the nuclear center, then mutual repulsion pushing opposing layers away from each other, and on top of that, outward pressure from the exterior layers. This continuous geometric tug-of-war is what supposedly keeps the entire atom perfectly stable. Let's walk through those layers step by step, heading straight toward the center. Out on the vast frontier, you have the electron layer. Take a step inward and you hit the anti-neutron layer, which, true to its name, has a reversed orientation. Pushing further in, we find the proton layer, confined in strict 90-degree increments. And finally, right at the bottom of the list, the innermost attractive shell, the neutron layer. Actually, I want to pause on that outermost electron shell for a second, because the RAM gives us a really elegant answer to a classic question. Why are atoms mostly empty space? According to this framework, that electron layer hangs out at a massive radial distance simply because there's no outer confining layer pushing back on it. Without an outer boundary squeezing it inward, the electron layer just naturally drifts way out. Bam! Vast empty space explained. All right, section 4, the Central Pyramidal Body. We've finally made it to the climax of our atomic journey. We've pierced through the empty space, through the protons and neutrons, right down to the absolute dead center of the nucleus. And here's the crucial point. At the core, this model completely breaks all the rules we just learned. Unlike those single quark particles doing their solitary Gaussian orbits, the central pyramidal body is a massive exception. It's built of 3 mutually perpendicular quarks doing a collective circular motion with synchronized vertical jumps. Yeah, jumps. This bizarre tri-quark pyramidal body is doing the heavy lifting for the whole atom. It's the hierarchical core of the nucleus.
It's hypothesized to act kind of like a Higgs entity, meaning it generates the effective mass density for the entire atom. Think of it as the ultimate anchor, the gravitational electromagnetic anchor, keeping this chaotic spinning system from just flying apart. But don't picture a stationary anchor. It is anything but still. The parts of this pyramidal core travel in a closed circle and then execute what the model calls synchronized collective up and down jumps. Literally picture these three perpendicular quarks furiously bouncing, half upward, half downward, in perfect, relentless synchronization. So what exactly happens when you've got a heavy core frantically bouncing up and down at the center of an atom? The source material explains it beautifully. This coherent oscillation imparts a periodic vertical displacement to the entire nucleus and its surrounding envelopes, resulting in a holistic periodic vibration of the atom. In plain English, the entire atom is constantly vibrating and ringing like a struck bell, all thanks to that bouncy pyramidal core. Which leads us to our final part, Section 5, Theory versus Reality. As cool as all this bouncing architecture is, we need to bring things back down to Earth and look at the actual scientific status of this model. This synthesis brilliantly wraps up what we've been covering. You've got the single-quark particles with their orientation-based behavior. Contrast that with the central pyramidal body, making up the nuclear mass center with those three perpendicular quarks. And of course, the electron layer, pushed way out to explain atomic volume. It's a remarkably well-organized system. And before we wrap, I really want to emphasize this one core tenet from the text. All particles are in continuous motion. Stationary states are absent. Nothing, and I mean absolutely nothing, is standing still in the Rihan Atomic Model. From the outer electron void right down to the jumping core, it's a deeply kinetic, dynamic framework. So why are physicists actually giving this the time of day? Well, it offers a visually and mechanically intuitive way to look at atomic architecture. By moving away from the static composites of the standard model, it's making a bold attempt to bridge the infamously huge gap between classical and quantum descriptions. And it's doing it entirely through explicit geometric mechanisms like those Euler rotations. However, let's be absolutely clear about where we stand. The Rihan Atomic Model is, right now, a proposed theoretical framework. It is entirely awaiting experimental validation and hard quantitative predictions. We're exploring it today because the geometric elegance is undeniably fascinating. But in the realm of real science, a model is just a model until it's backed up by observable data. But hey, exploring the theoretical is exactly how science pushes the boundaries. So I'll leave you with this. If the very identity of a particle, the thing that determines whether it builds a burning star or a living human cell, is dictated simply by its geometric orientation in space, what else might we be completely misunderstanding about the fundamental fabric of reality? Thanks for hanging out with me for this explainer today. Keep questioning, keep visualizing, and I'll see you next time.